bad video. You can see my screen, right?
We're waiting for the screen. Yes.
Yeah. Now, yes. Okay. Super. Okay, hello everyone. Assalamu alaikum. I'm glad to be here today. Welcome to our session about Edge Computing 101, the what, how, and why. I know it's the end of the day, so I will try my best to make it light and simple. I also added some quizzes to make it more interactive, especially it is an online session and we are not seeing each other in person. I'm Mostafa Osama, EMEA Solutions Architect with Intel, focused on edge computing and AI. Before starting, I would like to thank the AWS team and the organizers who organized this session and the previous one, of course, and for inviting me to participate in today's webinar. Before digging into edge computing, what is edge computing and so on, let's start first by a quick overview of cloud computing. Cloud computing has made a big difference in the IT world. Now businesses can access applications, storage, development tools, and other cutting edge technology on demand over the internet, of course. The computing itself or the data processing happens on the cloud. For example, my image stored on Google Drive, the image in my phone in iCloud, for example. So the data here is the image and the storage location is Google Drive and so on. But in some cases, I need to bring the processing and the storage of data closer to its source to avoid, for example, latency. And also my application is sitting in a place where no internet coverage. So what shall I do? And from that, edge computing is the name of the game. Edge computing is computing or processing that's done at or near the source of the data. When I said the computing, I mean here that processing unit like itself, like for example, CPU, or any chip that helps me to do the processing. And as you know, we are living in the ubiquitous computing era, where every device we are communicating with has a chip, starting from my mobile phone up to the network base station or a smart car. But the main question that raised to my mind here is where data does come from. And the data is created by us human beings, for example, you and me, in our world, the environment that we operate in, the places where we do work. It comes from us in our interactions with the equipment, with your smartphone, with your smartwatch that we use, and we are performing various tasks. For example, take your smartwatch as an example. It has sensors that monitor your heart, your oxygen level, and so on. But today, more than 50 billion connected IT sensors and devices. It's really a very big number. Think of smartwatches as cameras used in stores and buildings, medical devices, mobile phones, smart cars. So many connected devices around us nowadays. And in fact, a report from Gartner predicts that more than 50% of enterprise data will be created and deployed outside the cloud by 2025. And the data is growing exponentially. So to brief it in a small sentence, edge computing is the practice of moving compute power physically closer to where data is generated. And by processing data at the edge computing reduces the need for example, large amount of data to travel between servers, the cloud, the devices, or edge location. So this is solving the infrastructure issues found in the traditional data processing nowadays, such as latency and bandwidth. Also, I have another example that will make it more clear for you. Take self-driving car as an example. Imagine someone is passing the road and your self-driving car has to come to a stop. That means the action should be taken with no delay. No time to send the data to the cloud and wait the response back. And there is two kinds of edge computing capabilities that we often find in these environments. The first one is edge server, as you see here in the slide. There is a real server. You can think of it as basically a piece of IT equipment, maybe a hard rack or industrial PC or a ruggedized PC. But it's a piece of equipment that was built for the purpose of computing IT workloads. Another place, as you see in the bottom of the slide, where we can perform work in the edge itself. What we think here is it is called edge devices. So you can think of it as a sampling machine, for example, a turbine engine, it could be a robot, and it could be a car, of course. Okay, so edge computing has opportunities across many industries where large amount of data are more effectively processed, analyzed, and acted locally. So what is the benefit of edge computing? Here in Intel, we said that the edge is driven by 4 laws, as you see here in the screen. So law number 1 is law of physics. We wanted to reduce latency. How can I do that? By processing data at the edge. Data travel is reduced or eliminated, and this accelerating, for example, AI. So instead of sending the data to the cloud or data center and wait for the response back, this can make our life more easy. And this opens the door to advanced use cases with more complex AI models, for example, such as fully autonomous vehicles or self-driving cars, augmented reality, which require low latency. Law number 2 is law of economics. The cost of bandwidth. We wanted to reduce cost using, for example, our local area network for data processing means organization can access higher bandwidths and storage at lower cost. Additionally, because processing happens at the edge, less data needs to be sent to the cloud or data center for further processing. Law number 3 here is Murphy's law. Some areas are not connected to the internet, which make it hard to implement, for example, cloud-like solution. And edge computing is the best player here. And finally, law of the land. Respecting privacy laws and data security. When data is processed at the location, it is collected. Edge computing allows organizations, and most importantly, government, for example, to keep all of their data and the compute inside their network and the company firewall. Edge computing can be used really everywhere, from retail stores for self-checkouts, for example, and hospitals for remote surgeries, to warehouse with intelligent supply chain logistics, and factories with quality control inspection. So there are so many trends nowadays that you can combine with edge computing. And I wanted to talk about 3 technology trends that are connecting together and creating new use cases that are pushing the market to consider edge computing. So trend number 1 is ubiquitous compute. Everything we interact with involves computer technology that leads to big amount of generated data that we need to do action on. In your home, you have smartphone, you have smartwatches, you have, for example, Alexa from Amazon. You have so many things. So this will create really a very big number of data, and we want to make use of all of these data. Trend number 2 is artificial intelligence. Intelligent everywhere, turning infinite data into actionable insights. Example support examples support improve patient care and enhance medical diagnosis, help enable safe, smart, and efficient industrial applications, create more personalized, more convenient experience in retail, for example, help improve public safety with deep learning. You can see more cameras in the road nowadays that is taking a license plate, for example. And the trend number 3, pervasive connectivity. Everyone and everything is becoming connected. Thank you, 5G. So edge computing with AI, 5G, and the big amount of data in the wild helped us to explore new opportunities. Some trends in the internet about AI is driving computing to the edge. And in the past, AI is only happened in the big enterprise, but now there is a paradigm shift to enable AI at the edge. AI is moving to the edge with 5G, and the market of edge computing and AI software is growing and may reach to almost 30% compound annual growth ratio. And the Gartner expects that the adoption of adding AI at the edge is about 2 years to 5 years, which means so many industries are starting to focus on implementing edge AI solutions. So really, it's the next big thing here related to edge AI. But of course, we are not living in utopia, and every technology has a number of challenges. And I just wanted to talk about just one challenge here related to edge computing. In edge computing world, there is no one solution fits all. You have a smartwatch that has a specific chip. For your mobile phone, the same. For your assembly machine, the same, and so on and so forth. As we have so many use cases, that means we have so many requirements. So applications need, as I said, low power processor. Some application needs AI accelerator. Some application needs low temperature processor. For example, some application will be deployed in the retail stores, but other will be deployed under the sea, and so on. Which leads us to another challenge: how we can handle all of these hardwares, as each kind of data-centric hardware typically needs to be programmed using different languages and libraries, requiring maintaining separate code bases, a big headache to the developers. In addition, inconsistent tools support across platforms means developers have to waste time learning different set of tools. If you wanted to deploy your application on CPU, you need to learn how to compile your code on CPU. If you need to write your code on top of, for example, GPU, you need to know how to compile your code on GPU, and so on. That means that developing software for each hardware platform requires a separate investment with little ability to reuse that work to target different architecture. I wanted to put here that in the past, before heterogeneous system, that we only have a CPU, and we just program our application by using, for example, any programming language like Python, Java, C++, and so on, and the compiler will do the heavy lifting for you. But now we have so many chips, heterogeneous systems. We have CPUs, we have GPUs, we have FPGAs, we have VPUs, we have AI accelerators, and so many startups nowadays are working on implementing and creating AI chips. The multitude of hardware AI architecture in the market today, each with a separate software stack, make for an inefficient and unscalable approach for the developer ecosystem if they wanted to scale their application or they want to scale their platform or solution, for example. From that, Intel introduced to the community something called One API. One API, it is an industry initiative, encourages cross-industry collaboration on the One API specification to deliver a common developer experience across all accelerator architectures. Think of it as something like abstracting, API abstracting, for example. So you have the freedom to choose which hardware you want to implement your solution, CPU, GPUs, and so on. You can maintain the performance across the heterogeneous computing systems. And of course, you can write your code once and deploy anywhere. So this, as I mentioned, it is the stack of One API. And our main focus here is to help developers to deploy their application and to focus only on the application layer, not more into the hardware layer and what is in the bottom. And by asking developers, what do you care more about? So they said that they wanted to reuse their code. And wanted to give them the freedom to write the same code on different hardware. The same code written in CPU, and I wanted to scale it to GPU so I can use the same code on top of GPU. Take the full hardware performance. For example, Intel CPU has integrated GPU in the same die or the same chip itself. So the developers need to access these capabilities. And these are the main functions of One API. As you can see here in the slide, what most of the developers care, as I mentioned, is the framework, like AI frameworks, TensorFlow, PyTorch. So Intel is helping them to write their code once and put it anywhere. No matter what is the target hardware, or is it in the cloud or at the edge. Of course, if you need another level of control, you can use the layer below with pre-built libraries for different use cases like AI video processing. Okay. Here, I wanted to share with you that the One API ecosystem is growing with startups, big companies, and universities, and all of them have the same dream of having one programming model for the heterogeneous computing. And also, Intel is offering a free program called Intel Student Ambassador for One API. This program is focused on undergrad and grad students who are passionate about the technology and working with developer communities to promote learning, sharing, and the collaboration. You can scan the QR code and know more information. And of course, I am available to any more questions. So time for quizzes. So just I will just give you 1 minute. You can write the answer in the chat window, and Ola can handle these answers. So the quiz number 1, edge computing is computing that's done at or near the source of the data, true or false? I believe it's a simple question. Okay. Yes, it's true. This is the definition of edge computing. Quiz number 2. One of the benefits of edge computing is reduced latency, increased latency, no change in the latency. I don't know. I believe it's a simple one as well. Yes, if you write down answer number A, you are right. It's to reduce latency. Okay, super. So I just wanted to give you a quick refresh about the difference between training AI model and inferencing AI model. I don't know if you are aware of this or not, but just to give you a quick refresh. Training is the process of teaching the deep learning model to perform a desired AI task, such as image classification, or converting speech into text, for example, by feeding it data resulting in trained, and the resulting will be a trained deep learning model. For example, I want to build AI app to know if the image contains a bicycle or not. This is done by feeding the model with a lot of data or images containing bicycle. And once we reach to the required accuracy, the acquired performance, now we have deep learning inference. And inferencing is the process of using a trained deep learning model to make predictions against previously unseen data. In this example, for example, a new bicycle picture in your phone, for example. And here, what we use in the production inferencing and in the deployment of our edge computing solution. This is what we care more about, the inferencing part. One of Intel's tool that is powered by one API, of course, is Intel OpenVINO and used for AI inference. Intel CPUs are existing anywhere in the server, in your local machine, in the cloud. So what if we can optimize your deep learning performance on existing processor technologies? What if, as a developer, you could write once and deploy anywhere without the headache of what is the target platform I want to deploy my application on? So Intel OpenVINO toolkit is an open source tool that is not only helping optimize deep learning models, but also develops solutions using these models and ensure their quick deployment. That's not all. Also coupled with the optimized image and video processing pipeline, OpenVINO toolkit goes on to provide fast inferencing and deployment from cloud to the edge. It is one of the best tools in the market nowadays for neural network model optimization when the target device is Intel hardware like Intel CPU or integrated GPU. So in a nutshell, this is all you need to know about Intel OpenVINO. It's supported by all the most popular frameworks. It is supported by any Intel hardware architecture, and it's supported by any kind of operating system. And this is a key part of Intel AI software ecosystem. I just wanted to take you on a developer journey, a quick developer journey, of course, now, and show you how easy it is, in fact, to deploy an AI application with Intel OpenVINO toolkit. First of all, that Intel has created a repository called Open Model Zoo that contains hundreds of pre-trained models, ready models. When I said pre-trained model, I mean ready models, supported by the popular frameworks. I think it's more than 300 models for object detection, recognition, text and speech analysis models, image segmentation, human pose estimation, almost any kind of use case you need to help and to make it in your application, for example. The next part of our journey is optimization. So take your pre-trained model or your train model. So if you have a custom model or you already have, or you wanted to use a pre-trained model, so you can optimize it and run it on your base hardware, namely CPU or integrated GPU, without necessity to plug in any additional accelerator. So this is the main function for something called the model optimizer. It returns a form of a process model, which is called the intermediate representation, that is used to deploy our application on top of Intel hardware architecture. A simple example of how, by adding a small server, even if your local machine, to the camera, you can build the core detection application, as you can see here in the slide. We offer a variety of samples, tutorials, so you will be able to build something you love. Okay, so I love use cases, and what I like here that AI is existing in any industry. For example, here in healthcare, GE Healthcare is developing AI solutions across multiple radiology modalities to detect and help prioritize critical cases, for example. Inferencing of image data is a computationally intensive process that runs complex calculations. So by OpenVINO and by Intel AI technologies, we make it more simple for them, and without the need to send the data to the cloud and wait the response. All of this happen in their product, which is called the Critical Care Suite, to scan X-ray images and detect the collapsed lung within seconds at the point of care. Also, another example in healthcare, Siemens Healthcare Healthineers, sorry, is the global market leader in diagnostic image. And the company utilizes AI to help them to automate and standardize complex diagnostics to improve patient outcomes. And also by using Intel OpenVINO, they can detect the X-ray and what is the main issue in CT scan, for example, or so. Also, another example, Shanghai DeepSight has been developing a computer vision solution to detect the defects. So they put cameras in their factories, and this factories is able to detect the defects and scrapping products, for example. And this is done by Intel OpenVINO. I love this use case. DC Water, a leading utility based in US, that was looking for a more efficient and accurate way to inspect underground pipes for possible damage. And imagine that in the past, someone is going under the ground to inspect any damage in the pipe. It's really very hard. So DC Water turned it to one of our partners to co-develop a solution, and which uses deep learning based computer vision to automate the analysis of video from the pipes. Now, thanks to computer vision for detecting the damage with high accuracy. And our ecosystem is growing rapidly. And here are some other examples of companies are using Intel OpenVINO. I like here to put this slide that gives you the feeling to start testing and using OpenVINO. It is a collection of ready-to-run Jupyter notebooks for learning and experimenting with OpenVINO. You can start with these simple steps to turn your laptop into an AI powerhouse. And also, Intel offers a certificate related to Edge AI, so you can register and you can access the content for free, of course, and a real-world project codes that you will learn. Also, if you wanted to work without installation, we have a cloud platform called Intel Dev Cloud. It is a development sandbox to test and run your AI workload. And if you have, for example, Docker image and want to build a cloud-native application, we also have something called the Container Playground that you can import your Docker image and see the result of your AI application, without, of course, installing OpenVINO in your machine. Here is an example of how cloud and edge is combining together to build an end-to-end solution for any use cases and any challenges you are facing. Here we are using AWS services like AWS IoT, Greengrass, and SageMaker. So to put it simply, AWS IoT Greengrass seamlessly extends AWS to edge devices so they can act locally on the data they generate while still using the cloud for management, analytics, and durable storage. SageMaker is an well-known Amazon service that was designed to build and train and deploy machine learning models easily. For each step, there are tools and functions that make the development process faster. All the work can be done in Jupyter Notebook, which has pre-installed packages and libraries such as TensorFlow and Bands. Okay, so here in this diagram, we want to support the the cloud developer journey from cloud to the edge. So you can build and train your models in AWS using AWS SageMaker, and then optimize these models using OpenVINO Toolkit Model Optimizer. Once optimized your model, you will be able to benchmark your models in Intel Dev Cloud across Intel hardware architecture to see which hardware can fit your need, for example. And in the end, we want to showcase how you can set up your edge environment for Intel OpenVINO and AWS Greengrass, and deploy applications using Greengrass Python Lambda that leverage OpenVINO Toolkit on the edge to perform image classification and object detection. You can find this in our blog community. Okay, it's time for another quiz. So what is Intel OpenVINO? 10 seconds. Okay, so if you put your answer D, you are right. It's all above. It's a tool for deploying AI in Intel CPU and GPU, optimization tool, and support computer vision and NLP. Okay, another quiz. Intel Dev related to Intel Dev Cloud. You have also 10 seconds. Yes, if you said true, you're right. I wish you're in front of me to start interacting, but it's okay. Okay, so here my last slide, I just wanted to tell you that implementing edge computing with AI is a journey. So step number one, from my point of view, when it comes to getting started with edge AI, it's important to identify the right use case. For example, I want to increase customer experience in the retail store. I want to reduce out of stock rates by defining the end goal, which is, for example, I will implement AI shelf monitoring to provide real-time information based on in-store camera. A camera in front of the shelves, and if there is some product we wanted to know, is it still there or finished by the customer, for example. Second, we want to evaluate the data, and we want to evaluate the application requirement. Do I have the data to train AI model, for example, or if not, where will I get this data? Step number three is about understanding the edge infrastructure requirement. A recommendation start by looking at the existing infrastructure to understand what is already in place and what needs to be added. One of our partners is implementing and developing AI checkout solutions. So you can put your plates and the camera will recognize which foods are you putting, for example, burger, chicken, vegetables. And they asked us to help, and they were surprised that they can use the same processor they have to deploy their AI application. So that means we help them to reduce their cost or total cost ownership. Step number four, roll out your edge AI solution by making sure to know exactly which production environment you wanted to deploy. So in my testing environment, if I am putting my application on GPU, I need to make sure that also the target platform will be GPU or CPU and so on. The most important part from my point of view is to celebrate, because you have done amazing work through the journey. Okay, so key takeaways I wanted to mention here. Number one is edge computing is not about physical place or anything else. It's about how we compute. Also, one API is open, multi-vendor, multi-architecture, and adopted widely. Edge AI is the next wave of AI. Intel OpenVINO is an AI inference tool that optimized for amazing, and edge computing is a transformational journey. Enjoy your journey. I'm glad to be with you. I was glad to be with you today, and thank you so much for your time. To you, Ola.